Problem 0.11.5. So now we'll try to minimize this quadratic function f using the rank 1 correction method. We start from the initial point x naught equal to 0. Okay, so first recall the rank 1 correction formula that is given by that. Okay, so now for the specific question right here, since we need to use the gradient of f a lot, so we first compute the general formula for the gradient of f at any given point x. So the gradient of f, since it's a quadratic function, the gradient of f is just the qx minus b. The q is this, the b is this. So that's essentially the gradient of f at any given point x. So now starting from the x naught, which is 0, we can compute that the gradient is just this. Okay, and then from there we can compute the decay because it's just negative h times g, and that's this. Okay. And then this decay, this d0 will be used as a search direction, and we know that the formula for the step size will be just that. Okay, so you simply do the computation of the inner product of these two and then the inner product of this two. So you may compute the dq decay along the way, which is that. Okay, so now you finish the computation, you will figure out that the step size is just 2/3. So once you have the step size and you have the search direction, you can update your x naught to x1 by doing this simple update, and that is how you get the x1. So once you have the x1, you can compute the delta x naught, which is x1 minus x0, and the delta g0 is just the g1 minus g0, or it's equal to q times delta x0. Okay, either way you like. Then you can compute these two. Now once you have these two, you can throw into the we're going to update formula right here. So you want to compute the h1. So you chose the h naught to be identity as the first step, but now starting from the h1, you need to compute it using this rank 1 update formula. So we use that formula, the h1 is equal to h0 plus this thing, and you examine every term in this ratio, you see that you have computed them, right? This h naught, delta x naught is something computed, delta g naught is something already computed, h naught is identity, and I think everything else is clear. They have all been computed already. So now you get this, okay? And then taking the sum, and you get the h1. So once you have the h1, you can repeat this procedure. Just compute the decay, compute the d1, and then you can compute alpha 1, and then update your x1 to x2, so on and so forth. Okay, I'll save the next iteration, but the procedure is exactly the same.